Hey guys, Professor Doney back. We're in the middle of talking about circuits, DC circuits, and what I put together here is a little more complicated one. Why is it a little more complicated? Because it has some things in series. It also has a parallel, resistors in parallel, and it has a resistor in series with a parallel back in series with another resistor. So we're going to find out the total resistance or equivalent resistance of all these, the current flowing through, and the power. Alright, first thing we need to do is start dealing with some of these resistors. These are in series here, so we can replace those with a 20. And then we have this grouping here, which is now a 10 and a 20. It has basically become this now. We can treat those as parallel, and what that ends up being is 1 over 10 plus 1 over 20, which is 1 over 2 over 20 plus 1 over 20, which is 20 over 3. And 20 divided by 3 is 6.67. So what that ends up being is we can clean up that entire circuit, and it becomes a 10 on top, this new 6.67 here, and we still have the 10 on the bottom. Now that's an easy one to deal with because they are all now in series, so we just add those together, and what that becomes is one single equivalent resistance or total resistance of all those. Of adding that up, that comes out to be 26.67. So the total resistance is 26.67 ohms. That's the equivalent of all this, everything over here, everything on this side. Now if we continue and just use that equivalent with that 120 volt source, voltage source, we can go further and find out what the current is flowing through that circuit. And that comes from Ohm's law. We just rewrite it for current is voltage over resistance. That's going to be 120 over 26.67. So 120 divided by 26.67 gives us roughly about 4.5 amps. And that's the current that is flowing through that. Now we can use that to find power, because power is current times voltage. 4.5 times 120 volts times 120 tells us 540 watts, which is 0.54 kilowatts there. So that works out pretty nicely. It's a nice, good exam problem. Since we have another moment here, why don't we just make it a little longer and go through and find out the cost for 1 hour per day for 30 days while we're here. So we take the 0.54 kilowatts, we multiply it by the cost kilowatt per hour that they're charging us, and let's say they are charging us 14 cents per kilowatt hour. So we put 14 in there. It's going to be times, let's see, 1 hour per day, 30 days. And if we take 0.54 times 0.14, I think I moved that in my calculator, 0.14 times 30, it'll tell us that the cost that would be $2.67-ish to run that. Again, that's only half a kilowatt or 500 watts, not only, but it's not a ton. It's not like there's a lot of things plugged in there or that it draws a lot of power, things like that. So real good example for a potential exam, hint hint. And if you understand that, you're understanding series and parallel and calculating total current and power and cost. And also throw in here, if we had to put a fuse value in there, as long as the fuse value was greater than this 4.5, we are good. We won't blow the circuit. Alright, have a great day. We'll see you in the next video.